So welcome back students. I am here again with a new topic, that is semiconductor physics, and this section lies in the modern physics of your NCERT book. It will help you to score very good in your board exams. So be prepared with this topic. It is very easy to understand, and also it helps to build your concept in semiconductor physics. So in semiconductor physics, I have taken the topic PN diode that is used basically in every electronic devices that you have used or using in day to day life. So my presentation contains a few contents, that is introduction of the topic, PN junction formation, forward biased PN junction, how a reverse biased PN junction works, its VI characteristic, and at the end I will conclude the topic in short. So moving forward with the presentation, first you can see here a diagram in which there are two junctions. The grey section represents the P region and the green section represent the N section. I think you have studied in your chemistry section that how a P type semiconductor works. Basically it has a hole inside it, means it is always made up of a trivalent atom which can accept any electron from another atom. But in an N type it has a donor ion that it can donate the electron to any another atom, because in the outermost shell of these kind of atoms they have an extra electron. So here if we will be joining both the regions P and N section, we will get a semiconductor that will be known as PN diode, or a junction will be formed that will be known as PN junction. Now here you can see three diagrams, that is the 3D view of PN junction formation. Starting from the left hand side, the first diagram shows you about the diffusion of two junctions. Here we have joined both the junctions P and N section. Second diagram or middle diagram shows that there has been a concentration gradient created, means अगर आप holes को क्रिएट करते हो एक सेक्शन में और इलेक्ट्रॉन्स को एक सेक्शन में, तो वो ऑटोमेटिकली एक दूसरे को अट्रैक्ट करेंगे, बिकॉज इलेक्ट्रॉन हैज़ अ नेगेटिव चार्ज ऑन इट एंड एन hole has a positive charge on it. So due to this concentration gradient, they try to recombine or diffuse in its, both of the majority carriers try to diffuse in themselves. So due to this region, due to diffusion of electrons and holes, in the third diagram we can see that there has a creation of space charge region. You can see in the middle part of the third diagram that there is a absence of few majority carriers. Charges are present, although charges are present, but the majority carriers are separated at that region. This happens due to the concentration gradients. So here the formation of space charge region, or it is also known as depletion region, depletion layer has been created. So here you will be listening to a video, so carefully listen to it. It is going to explain the formation of space charge region in the absence of an external battery.
This is the region where the P type and the N type joins, or the junction which is formed, which is called as the PN junction. So this is the PN junction. While an equilibrium, now let's see, free electrons which are negatively charged are available in the N type. So this is the region where the P type and the N type joins, or the junction which is formed, which is called as the PN junction. So this is the PN junction. What happens when a PN junction is made? Electrons near the junction jump from N-type semiconductor towards the P-type semiconductor. Free electrons with region. An electric field is also created in this space charged region because of the movement of these holes and the electrons, and the direction of the electric field is from the N-type region towards the P-type region. Some electrons move back from P to the N in reached at this region. This movement of electrons and holes in the space charged region gives rise to a current, and this current is called as diffusion current.
So here you can see a diagram which I have made to explain you about the diffusion and a drift current. This is the P region, this is the N region. They have been joined together. This is the junction point. The P region contains all the holes and the N region contains all the electrons. What happens without an electric field, due to presence of concentration gradient, automatically the electron starts moving towards the hole, or you can say they get attracted towards the hole, and the holes also move towards the electron and they recombine, they start recombining. So we get a space charge region. This is also called as depletion region for us. Depletion region means here all the majority carriers and the minority carriers are absent. Although charges are present, यहाँ पे जो भी होल रिकम्बाइन होगा वो अपने पीछे एक इलेक्ट्रॉन को लीव करता जाएगा, और इस साइड में एन साइड में इलेक्ट्रॉन होल के साथ कंबाइन होके इस साइड में अपने पॉजिटिव चार्जेस को लीव करते जाएगी. सो इधर नेगेटिव एंड इधर पॉजिटिव चार्ज, एक तरह से यहाँ पे एक इलेक्ट्रिक फील्ड बन जाएगी, विच यू कैन सी इन द थर्ड डायग्राम. दिस वॉज द फर्स्ट डायग्राम, the raw structure of a p-n junction. Then due to the difference of concentration of holes and electrons, we can see here the depletion region. After that we can see the third diagram, where you can see here the electrons or negative charges and here the positive charges have been formed, and this is called the depletion region. Due to the formation of positive and negative charges, a electric field will start acting on this p-n junction, and here due to the diffusion of electrons and holes at both the sides, we get a diffusion current. Due to the recombination of electron and holes, we get a diffusion current which starts flowing in this p-n junction. Now we don't have a battery in all these structures, you can see, but now before understanding forward biased, before understanding the forward bias condition in a p-n junction, I can show you that here we have connected a battery to the p-n junction. At the left hand side, we all know we have holes, but at the N side we all know that we have electrons in this junction. This is P region and this is N region, and the forward bias condition arises when we connect the P region to the positive side of the battery and the N region to the negative side of the battery. So this condition arises, that is known as forward bias. Due to this connection, the hole starts drifting towards the N region, or where the electrons are situated, while the electron starts drifting towards the hole region. Due to this, a current starts working in this diode, that is known as drift current, which actually arises due to drifting of electron and holes in effect of the external field. So there are two conditions for being a forward biased in a p-n diode. First, we have to connect the positive terminal of the battery to the P region, and negative terminal should be connected to the N region. And the second condition is the junction shrinks or the depletion region narrows or thins. यहाँ हम देख सकते हैं, since the drifting of holes and currents and due to recombination, this junction gets decreased. यहाँ से ज़्यादा holes इस तरफ जाने लगेंगे, तो automatically ये junction क्या होगा, shrink होता जाएगा. And opposite to this criteria, in a reverse bias mode, we have to connect the negative side of the battery to the P region and the positive side of the battery to the N region. इसमें क्या होगा, जस्ट हमने opposite connection कर दिया है. अब हमें पता है कि हमेशा पॉजिटिव चार्जेस जो हैं वो नेगेटिव की तरफ अट्रैक्ट होते हैं, तो हमने बैटरी को कनेक्ट किया है. So due to this, all the holes will start accumulating at the corner of this P region. और ये सारे holes क्या चाहेंगे, we should move towards the negative terminal of the battery, while these electrons will try to move towards the positive terminal of the battery, and the accumulation of electrons will start acting at this region. इससे होगा क्या, our depletion width will be increased. This region is actually the depletion region. So we can see here in a negative biased condition that depletion region is increasing, the width of the depletion region is increasing. So we are having three conditions in a reverse bias mode. Connection is opposite compared to the forward bias condition. यहाँ पे negative battery P region या holes के side से connected है, और positive terminal of the battery is connected to the electron side or the N region. Second condition is that इलेक्ट्रॉन एंड होल्स ब्रेक डाउन थ्रू द पी एन जंक्शन. क्यों ब्रेक डाउन हो जाएंगे, एक कंडीशन ऐसी आएगी व्हेन दे विल कीप मूविंग एट द आउटर स्कर्ट्स ऑफ द पी एन जंक्शन, एंड आफ्टर अ पॉइंट व्हेन होल ऑफ द चार्जेस मेजॉरिटी कैरियर्स आर गॉन, दे हैवंट रिकम्बाइंड, तो ये विड्थ बढ़ते बढ़ते ब्रेक डाउन की कंडीशन आ जाएगी. उससे ज़्यादा अब एक्यूमुलेशन नहीं हो सकता है चार्जेस का, अगर हम बैटरी से पावर दें तो भी, तो ब्रेक डाउन हो जाएगा थ्रू द पी एन जंक्शन, एंड दिस रिजल्ट्स इन अ करेंट टू फ्लो थ्रू द सर्किट. इस सर्किट में करंट फ्लो करने लगेगी, एंड दिस ब्रेक डाउन इज कॉल्ड एवलांची ब्रेक डाउन. एंड अ पॉइंट टू बी नोटेड, अगर हम ज़्यादा बढ़ा देते हैं बैटरी की पावर को और ज़्यादा से ज़्यादा चार्जेस एक्यूमुलेट होने लग जाते हैं एट द रीजन, एक कंडीशन ऐसी आती है जब ये जंक्शन ब्रेक डाउन भी कर सकता है, मींस ये हीटअप होके ब्रेक हो सकता है या फिर शॉर्ट सर्किट हो सकता है, बिकॉज वो उनकी एक लिमिट होती है. एवरी डायोड और एवरी सेमीकंडक्टर डिवाइस हैज़ अ लिमिट कि वो कितने वोल्टेज को अपने अंदर बियर कर सकता है, या फिर उसके बाद अब वो नहीं वर्क करेगा तो ब्रेक डाउन हो जाएगा. It has a limit. So here in the reverse bias condition, we can say that there a breakdown can occur, and due to that breakdown we called it avalanche breakdown, and it occurs since electron and holes break down through the p-n junction. ये recombine नहीं हो रहे हैं और ये opposite direction में end पे जा रहे हैं. So thank you for watching my channel, and please like my channel, and if you want to know more concept about physics and mathematics, please subscribe my channel. Thank you.